Okay, so I'm going to talk a little bit about this Venn diagram. So I've got the upstream, midstream, downstream, like I said. So here's kind of how I see it. The API 510 is between the oil fields and the refineries is going to be used the most there. There are some vessels in midstream, but I think mostly it's going to be between upstream and downstream. And then the API 560, 563 and welding procedures and inspection, you know, you're going to have those in all three. And then the API 570, that was kind of a new one on me, and I think the reason that it's new to me is because in the upstream you don't see it that much because it calls out piping inspection per B313. Let me zoom in here. So it's per B313, and B313 people have it in the plant, but then outside the fence you're going to have either B314 or 318. Depending if you have oil or natural gas. So if you're on the pipelining side, you're going to have one of those two. In the field, you're either going to have B314, 318, or some kind of water spec. A lot of times people will use 314 for the water, or in California or other areas where there's a lot of steam, sometimes people will use B313 even outside the fence line, but that's pretty rare in the other areas. Sometimes people will use like a HDPE or PVC for the water. If you don't have a lot of heat, that's pretty common. Some other things that are kind of different. In the upstream side, you have a lot of stuff that's not really to do with the above ground. So your main asset in upstream is your oil itself and the stuff that's in the reservoir. So if you look at the kind of a sense of perspective for an upstream oil company, if your oil company has a stock market value, you know, 6 gazillion, which I understand is not really not a technical term, but 5.9 gazillion is your oil in the reservoir, and 0.1 gazillion is the stuff that we deal with day to day, like the piping, the tanks, even the platforms, as expensive as they are, really in the larger scheme of things are not a big part of the value of the company. Really, the big part of the value of the company is actually the oil in the ground. So people really get concerned about the reserves and that kind of thing. I mean, there are a lot of people working on the piping and stuff like that. It's not that it's not important, but it's a bigger deal, the reserves. So like drilling, fracking, the geology, stuff like that is a bigger deal. One thing that's in common with the downstream part is that we have piping networks, we have piping manifolds in upstream, whereas in the midstream they have that in the facilities, in the terminals, in the shipping hubs. But in between, in the pipelines proper, they have like one long linear feature that goes across the countryside, and they don't really have so much a network like manifolds and valving and that kind of stuff. So that's in common very much. And one thing that's very different between upstream and midstream and downstream is midstream and downstream, the regulation is much more homogeneous because it's more federally driven, whereas upstream, the oil fields, are more state to state. So the regulations vary a lot. It's literally different from one state to the next as to the regulations on the drilling of the wells in particular, and also the valuation of the oil. So for example, in California there's not, the oil is not taxed at the state level. It's taxed as a property at the county level. So it's very different from, say, where you have a state excise tax, you know, at the state level in other states. It's just crazy. In upstream, you have a lot more to do with water. So people have to get water for fracking, they have to get water for water injection, water for steam injection. And then when the water comes back out of the wells, you got clean minerals out of it. And so there's a lot of this water processing, piping water hither and thither. Water actually is a nasty fluid. So water is corrosive, it eats the piping, it's a big problem. And so that's a big business on the upstream side that you don't really have. You don't have it whatsoever in midstream, and you have a lot less of it in the refineries. And in upstream and midstream, you have DOT involved, so more so in midstream. We didn't deal with it so much in upstream. I had a couple projects that were to do with midstream, and the DOT regulated pipelines, you have the OQ, which is a pain in the butt. And then, like I said, you have B314, 318 in midstream, and then also in upstream. I've never heard anybody use B312. I've never used it. I've used B311 for steam boilers, 312 31.3 I've used, 31.4. I don't know if there's such a thing as 31.5 and 31.6. Never heard of them. 31.7, never heard of it. 31.8 I've used. I don't know if there's a 9 or a 10. This is pretty much federal. There's no water. You don't ever have equipment that's more than, say, 10 feet below the ground, whereas in oil and gas you do. Upstream oil and gas, it's all linear stuff, and it's all clean. So these guys will not accept gas that's got more than like 3% CO2, and a lot of them are saying 0.3%. They won't accept more than a certain amount of H2S, whereas in the upstream side, there's H2S in it. It comes out of the well, and you cannot tell Mother Nature, hey, don't put H2S in our gas. You cannot specify what's coming at you, whereas these guys, they can do that. Refining, you know, all this stuff. So huge process burners, you know, small amounts of water, and the most challenging process conditions. So in the refineries, you've got these high temperatures and pressures, and that's going to drive people, even if you didn't have a requirement to use API 510, 570, people are going to intensely focus on that because you just do have these like really high temperatures, really high pressures that you don't see anywhere else. Even with the steam injection, the highest like injection temperatures are like 600 degrees Fahrenheit, so they're tiny, right? So that's different. I also wanted to take a look at, this is an excerpt from one of my classes. These are some of the gathering and distribution systems, like the piping systems. So we have upstream, which is oil fields, midstream, which is pipelines, and tanker ships and railroads, but pipelines are the main thing, and then downstream. This is pretty typical. The oil, water, gas, and dirt comes out of the wells all mixed together. You go through some separation equipment, separate off mostly your water. With a free water knockout, any water that just comes off freely will drop out there. You heat it in this treater tank, and then basically you sell the oil, and it's all good. You know, you don't have to mess with the oil very much. But then the water, you may have a really elaborate system here. You may have a less elaborate system. You go through this so-called LACT, Least Automated Custody Transfer Meter, and then they'll go into the midstream system one way or another. And the gas may go through a more or less elaborate system and be shipped. So there's various types of these piping systems in the upstream. You have the gathering system, can be pretty elaborate to collect the fluids from the wells, and then distribution systems to take waste fluids usually back out to the wells, or enhanced oil recovery fluids like steam injection or CO2 injection, water injection, to push fluids out of the reservoir and into the producing wells. And the type of the reservoir is going to determine what kind of stuff you might be injecting. There's a bunch of different terminology, just different jargon terms that really confuses people, and so that's one of the things I go through in my classes, and that jargon, there's no really good place to look that up. So that's one of the things that I cover a lot in my classes. It's not just the piping, it's the tanks, it's the wells, it's all that crap, and so that's one of the main things that I focus on. And then the pipe, there's the line pipe, which is the stuff used on the surface. That's your Schedule 80, Schedule 40, and then the other stuff, like you might have fiberglass, you might have PVC, and it's different stuff. You do see like this C900, C905 that you see in municipal service, but generally we don't have the other stuff those guys have, like ductile iron. We don't run it. We just don't have that kind of stuff. But then we have some other stuff you don't see elsewhere, like OCTG, which is your casing and tubing that you run down the wells. And the metallurgy is different, and then it's got to support the tension. You're going to hang the pipe from it. So the threads on it are not your normal NPS threads that you have in the surface piping. And then you have your drill pipe and collars that your bit is on the bottom of, and that's this heavy duty stuff down here. It's got to transmit the torque to the bit at the bottom of the well. So that stuff's different. We have your usual ANSI 150, 300, 600, 900, 1500, 2500. 2500 I have never run. 1500 you see in steam injection service. If you're not in the steam injection areas, usually the highest you see is about 600. We also have these API 800 valves. I don't know if you see those in the refineries. I would guess probably not. And then you see some just like manufacturers. I don't know who specifies those, but there's manufacturers' valves that they declare ratings for those. Those usually are ductile iron. Okay, and then I'm skipping to a different section of my class here. One thing that is changing a lot and that is confusing people in upstream is that upstream is becoming more like midstream. It used to be that our pipeline in upstream were the little short pipelines, and the pipelines in midstream were the big, long pipelines. But what's happening is, it used to be that, okay, this is a cross-section, it used to be oil fields were little and they were centered over anticlines, so they'd be a few miles across. But with the shale drilling, you can drill wells that oil fields go for miles and miles and miles in extent. And so the pipelines, accordingly, have got to follow across those oil fields for miles and miles and miles. This is making our pipelines more like the midstream pipelines. So these are all midstream pipelines on this map. Each of these little gray squares here is a square mile, and you can see their pipelines go for miles and miles and miles. This is midstream pipelines, these little skinny ones, and this fat one on here is 50 miles long, and that's the biggest pipeline system I've ever worked on in upstream. So our pipelines are starting to approach the length of their pipelines, but the upstream pipelines have feeder lines. So this pipeline system that's 50 miles long also has 10 miles of branches coming off of it off to the sides, which is different from all these skinny midstream lines, which are just a single line going off across the country. They don't have branches going out of them, so that's different. If you look at upstream versus midstream, this is an upstream system in California, and it's above ground, so that's why I'm showing it, because if you had it below ground, it doesn't look good on a slide, right? But below ground systems like in Colorado are every bit as complex. They're just below the ground. If you have a midstream system, it doesn't have this many pipes in parallel. They just got the one pipe, right? Or maybe two pipes or something. But you have all these pipes, and it looks linear, but it's a branched system. I mean, they're all coming together. It's a header. Somewhere all those header together. Okay, so that's what I had.